Hey everybody. Today I'm going to do a demo of a software development lifecycle using Claude Code, which is generative AI. Claude Code was released about 2 months ago in May of 2025. So this is kind of bleeding edge AI development tools. One of my motivations for doing this demo is to show kind of what the state of the art is, because I think people are still kind of using mobile applications and websites to generate code one little chunk at a time. Claude Code goes a lot faster and does a lot more with a lot less overhead. I just want to show what's possible. I'm doing development on my iPad today. The only thing I've done on this project so far is create a directory, git init it, and I created a GitHub repo in the background that I can push code to so people can see it later. I haven't done anything, haven't tried this before. I just have a few notes of what I want to try during the course of this demo. We'll go through all that a little bit one at a time. Claude Code is entirely terminal driven, so I do have visual code running, but there's no files yet to really see. And we can look at the files as we go through, but we shouldn't really need to for the most part. All right, so let's get started. First thing, let's fire up Claude. Thanks for firing up Claude. Normally what you would do at this point, if you had an existing repo, is type init. So we don't have and what init does is it actually scans through all the code. It figures out the architecture, figures out key commands like building and linting and testing and things like that. And it writes them all in like a human readable format in a markdown file called claude.md. We don't have a repo right now, so we wouldn't do this. But generally that claude.md gets read in as context. So we won't have that context to start with, but if you had an existing project, that's where you would start, and it would jump right in with being really intelligent already. Let me start by doing something first. I'm going to go ahead and I'm running in tmux right now, so let me create a new tmux window. I'll do date. All right, so that's when we're going to start writing our code, just so we can see how much time it's going to take. Let me switch back to my other window here. All right, so I don't really have a plan for what this project is going to be, so it's going to be a little bit freewheeling here. But let me start off by researching web APIs that don't require keys. And we'll just create like a web-based API application. Trick number one, like don't be shy in writing a lot for your prompts. Like be very verbose. Don't try and write like one sentence. Most of the time that's not going to work out for you. So, all right, here we go with our first prompt. I am doing a demo of AI generated, AI created code. I want to build a web application that calls free open web APIs. I don't think you guys want to listen to me talk, so I'll just power through some of this, and I'll probably fast forward this when I go through editing. All right, so here's my first prompt. There's a few things in here to point out. One is that I'm writing it to a markdown file, design/webapis.md. One of the best practices I've learned is when you're going through these prompts, it's best to write out a lot of the design requirements, implementation steps to markdowns and actually commit them to GitHub, because it's good for the AI to be able to refer back to them later for consistency. You'll also know that I'm being very verbose in my prompt and repeating myself a lot. That actually helps it pick up on which things are key to me. And then finally, I'm prescriptive in what I want to see in the output, so that it is going to create a file that has all the things that I want to see in it. Note that by telling it to enumerate pros and cons and how well documented it is and things like that, it forces it to actually do that research. So sometimes if you don't specify those sorts of things in the output, it won't actually do that step. Let me run this first prompt and we'll talk a little bit about what it's doing. So You can see that it's chewing up tokens here. That's the context being sent back to Claude. You'll notice now that it's actually going through and doing a web search for me. Free public APIs, no authentication, required 2025. I didn't mention 2025. I guess it decided that was a criteria. It's going to go through. It has all these tools built into it where it can iterate through all the different steps that it needs to do to complete the task that I just gave it. I didn't need to tell it where to search or what to search or anything like that. Note that there's a global Claude.md context as well that sets permissions. I have it currently set up so it doesn't have to prompt me for permission to do web searches or web fetches. I don't really have any local resources exposed over HTTP that I'm concerned about it grabbing or discovering and pulling in. But as we go through this demo, you'll see that for some of the tools and commands it runs, it prompts you for permission to actually run those tools. It's like what a good security, safety, privacy feature, also kind of a pain in the butt. So we'll see that as we go through. Here we go, the still researching. You'll notice that it's moved on to its second web search, now Joke API. I'm going to let it run for a few minutes here, and we'll check back in when it's done running through all the different web searches and finding an API for us. All right, now it's asking for permission to actually write out a report. We'll say yes. Don't ask again for creating files or editing files during this session. Again, that's the nice little security feature there. All right, it's created a report. You'll notice at the top of my screen, I get a little pushover notification. That's a little custom thing I built for myself because, again, every time it stops to ask for permissions or when you step away for 3 minutes to go do something else, it's nice to get a little prompt that your AI is waiting for you. So let's pop over to Visual Studio here. We have our design file. All right, here's our free web APIs for demo project. It likes the Joke API, likes the board API, trivial data database. Can I has dad joke? Ooh, I'm in it for the dad jokes. That might be fun. Ooh, Pokey API. Let's do a Pokemon app. That seems kind of cool. Can be overwhelming due to data complexity. Seems like a good demo. All right, we're building a Pokemon app. That's what we're doing here. All right, so first things first, let's make sure that we can actually connect to the API. I will create another prompt here. I'm actually going to do a full implementation. I don't know that I would normally do like a little architectural spike prototype at this point, but again, I haven't done any prep for this demo, so I just want to make sure that this is actually going to work. I'll create another prompt here, and then I'll talk through it in just a sec. All right, so what we're doing now is we're trying out the Poke API. We just want to know if it's going to work. I said to keep it simple. I also gave it like one of the key tricks that I learned, which is like run your code. If it has errors, then iterate. Keeps it from like coming back to me and saying like, it works. AI loves to lie and say it works when it hasn't even tried it out. It also makes it so that the AI will iterate on it and find the errors, fix the errors, run it again. Usually it works, sometimes it doesn't. But this will go through and prove that we can actually exercise the API, and then we'll go through and we'll actually create implementation of the Poke API. So we'll let it run for a second here. It looks like it's going to go through and try basic Pokemon endpoint. You'll notice that it creates its own to-do list. So it's structured out its own approach to how to actually solve this problem. It knows about abilities, moves, types, which are Pokemon-specific things that it's learned from the website now. It's testing error handling. All right, so here's our first real prompt for security purposes. You'll notice I got my little pushover notification up there. Node, is it okay if I run Node? Yeah, sure. Don't ask me again for Node in the future. So now it's actually trying out its little test here, SSL routines, wrong version. All right, looks like it's got a little problem it's going to work through for us here. Oh, cool. We're going to do a little npm init. All right, look, it's actually creating a little project scaffolding for us. That was later on my list, but we'll see how this goes. And we're going to install Axios. Axios is a NPM package for doing web calls. I'm not sure why it's not just using the NPM fetch. Actually, let me ask. All right, so I hit escape. We're going to interrupt Claude here, and we're going to ask, why not just use the Node.js built-in fetch call instead of Axios? Might have a good answer. It might not. It might just switch. You're absolutely right. All right. When it says you're absolutely right, again, it's probably lying or frequently lying. It'll tell you you're right a lot and make really bad decisions based on user input. So you have to be really careful about that as well. All right. So we're going to continue chugging through. All right. Now it's checking in to see if it can actually hit that API with curl. Yeah, that's cool. You can run curl as much as you want. I don't care. SSL proxy issue. Let me check if we're behind a proxy. We aren't. I don't know what problem you're having here. All right, so it's hit a little bit of a snag. It doesn't look like it can hit this Pokey API here. It's going to try some other APIs that it found. Let's see if it can hit those instead. So again, I'm not telling it to do anything here. It's just working around the problems as it finds them. All right, looks like we're going to pivot here. Doesn't look like it's going to be the Pokey API. Looks like we're getting back our report of the Pokey API over here. All right, let's see what it says. All right, so you'll notice that it installed a bunch of APIs now. I don't know if it cleaned up. We still have our dependency for Axios over here. We'll have to clean that up later. That's okay. Pokey API. Use fetch, connectivity results, network issue, fetch failed, SSL routines wrong version number. Based on the API architecture, documentation seems to be correct. Let's see if we can use it without HTTPS. All right, so it'll answer questions for us too. And this is actually one of the cool things about it. It will go through your code base and you can just ask it questions about your code base and it'll answer questions too. So it's fully conversational. It'll answer questions for you and things like that. So it's gonna go answer my question right now. You'll note that I violated my own, like, hey, be really verbose in your prompts. This one's pretty simple. It's building up context right now, so it's not just working off of that single fire prompt that I just fired off right there. It's going back and pulling from the context, so there's a lot more going into it than just that one single prompt. All right, let's see if it can hit the API with just HTTP. Maybe if this doesn't work, I'll try one more thing to try and figure out how to get this Pokey API to work, because I really want the Pokey API. That sounds like fun. All right, looks like Pokey API is being intercepted. I don't know if that's because I'm using the Cloudflare safety NS or something else, but let's pivot here. You can go back to one of our other APIs. Let's do... Can I has dad joke? All right, we're gonna try this one out. All right, looks like this is gonna be our API. Looks like we're up and running here. Let's see what it came up with. Total pass, 7 out of 7. Can get ID. Again, like sometimes it lies about these things. We'll see how it goes. You know, I'm pretty confident this is gonna work. Invalid joke IDs return 200 with HTML error instead of 404. Doesn't affect. All right, well, seems good. Required headers. All right, I think this is going to work. All right, so the next trick here is this: all the commands that we just ran, all the prompts that we just ran, created a bunch of context. So what we're going to do is we're going to do clear. Claude has a 200,000 token context window that it'll pass in. That's like, I don't know, a set of encyclopedias or something like that. And it just keeps building up and keeps building up. I'm getting billed by the token here. So let's see, status. Default is Opus 4 up until 50% of usage limit, then Sonnet. We're currently on Opus. So I want to stay on Opus, so I'm going to clear my context so that I don't use up all my tokens on context that I don't really need. We could also do compact if we want. That happens automatically once you get to 200,000 tokens. It just smushes down all your context into a summary of your context. All right, so we're starting fresh. Let me create a new prompt. We're going to create a design for a new application here. All right, this is a little bit more loosey-goosey than most of my prompts would be because I don't really have any specific ideas about how we're going to test this API or use this API. Basically, an endless scrolling joke website. It'll give us some recommendations of other ways to use it. It's going to come up with a React or Vue framework that we want to use, and it'll write it out as a initial design. So let's go ahead and fire this off and see what we get. Alrighty, so here's our plan here. Initial design, framework, React with Next.js, mature ecosystem, developer experience, TypeScript, widely used. All right, seems good to me. Scrolling animations, progressive loading, pull to refresh, joke cards, 3D flip animation to reveal punchlines. Love it. Share functionality, my favorite like system with local storage persistence. All right, cool. Like, we're actually gonna do some crazy stuff here. Personalization. All right, so it's got separated out into a bunch of different steps here. These are going to turn into our implementation plan, I'm pretty sure. Gamification. Ooh, I love this. Man, it's smarter than me. It came up with a really good plan here. Technical architecture, front end, TypeScript, Tailwind CSS. Ooh, let's do a little UX design after this. UI components, Radix UI, key libraries, Axios for API. All right, I think that's good. Component infrastructure, component structure, state management. Yeah, looks like it's pretty good in here. I just thought of something. I don't know if there's like potty words in this API or not. Let me update the document here. The design looks great. All right, design looks great. We need this to be safe for work. I wanted to see if it can find like a content filter module on NPM, the repository listing. See if one already exists so I don't have to write something new. One of the things to note is like AI loves writing code from scratch. If you don't ask it to find modules or reuse code, it will write everything from scratch. So let's see if it can find a module that's up to date and it has a filter built into it. If not, we'll just write one from scratch. All right, here we go. Alrighty. Looks like we have our design in here. Let's see how it updated it. All right, so let's see. Obscenity, profanity detection using obscenity. Looks good. Content filtering. You'll note that it like created a whole section on content filtering, which gives it a lot more weight than other parts of the experience or other parts of the design now. When you ask a Gen AI a question, it tends to like give you a really heavy weight on the questions you asked. Note that it also did this like obscenity content filtering recommended thing. Like this is a sure sign that like Gen AI is creating a project. You can always look for that as like a landmark that something was generated by Gen AI. All right, I think we have, phase one includes real-time content moderation. Cool, we're in. One thing I don't know, like I've never used Next.js before. I don't know if it uses Vite or something else. So let me ask some questions about Next.js. Does Next.js use Vite? Or how does it compile and serve React and TypeScript files? It handles all compilation automatically, integrated through its keychain. All right, so it's not using Vite. It's using server-side rendering. All right, fine, whatever. Like, I've never used this before. I assume it's going to be fine. I assume there's a lot of examples out there that we can draw from if we get stuck. All right. Cool. Let's create our implementation. I'm going to clear our, maybe I'll leave our context. All right. All right, so it's up and running on my next one. We're going to use the obscenity NPM package here. I don't usually tell it to create scaffolding. Usually it figures that out by itself. I did use the keywords think harder, which gives the LLM more time. You'll see like these thinking prompts now where it's actually thinking more. And I told it to give it some success criteria to make sure our plan has enough details in it, make sure that it's going to test the code, it's maintainable, it's well architected. So one of the reasons I told it to think harder is because I want the LLM to take more time, burn through more tokens, and just generally come up with an implementation that we can believe in. This is kind of a critical step in the AI SDLC, so we need to make sure that it gets right. So it's worth burning a few more tokens on this step to make sure that we get it right. So it's going to go through, create a plan for us, project setup, scaffolding, implementations of features, core features, quality and testing, and it's going to come back. So we'll give it a few minutes. It's going to take a little bit longer here because I asked it to think harder. You can tell that it's already starting to burn through tokens at a higher rate here. So let's give it a few minutes. We'll come back and see where we're at. All right, looks like we're ready to go here. Let's see what I came up with for a implementation plan. All right, phase 0, 1 to 3 days. It's not gonna take that long. Functional website, unit test coverage, solid architecture. All right, looks like it captured our criteria here. Phase 0 is project setup and foundation. Success criteria, ESLint runs without configuration errors. Prettier, all right, fine, we can use prettier. I don't usually. Configured Jest, looks like we're gonna use Jest for testing. UI, UX dependencies, cool. Looks like that's headed on the right track. Success criteria, define base types. Okay, success criteria. Phase 1, content filtering system. Looks like that's good. Yeah, I wrote a long design here. SWR hooks, okay, success criteria, hooks handle, yeah, that looks good. Core UI components, all right, so when we get to phase 3, that's when things start really getting interesting. Add virtual scrolling, success criteria, search and filtering UI. All right, looks like it's got what it thinks is a month's worth of work laid out for us. User preferences and storage, that's fun, let's do that. All right, well, I think this generally looks good. Sometimes it includes some more things down at the bottom. Yeah, it looks like it has a little maintenance plan, dependency updates, documentation requirements, conclusion. All right, looks like we're good to go. I don't know if it included a README. No, it didn't include a README. Add a README. Whoops. All right, so we're going to add more code examples. That was one of the notes that I'd made to myself as part of the SDLCs. You always want to include code examples because that'll help frame out its current context of how it's thinking about these examples, and then it gives it a starting point for future implementations. Alrighty, looks like we're ready to rock and roll. All right, so we have code here. It hallucinated a little bit as we're going through this. There's something about 0.01 or some sort of percent thing that it did. Cache hit rate, 80%. Where'd it go? Oh, here we go. Filter service detects inappropriate content with, I don't know how we would ever really make sure about that. I don't really care about obfuscation attempts. Detailed analytics, yeah, not in it for that. Added some other things that were kind of interesting. Let's go back and see what it did. So let's see. We're going to scroll up through our little log here a little bit. Monitoring dashboard. I don't know that I want a monitoring dashboard, do I? All right, let's go in here. Do I want a monitoring dashboard? Yeah, I don't think so. Not in it for that. Let's see what else we got. Web Vitals reporting. Yeah, I don't know if I want that. We'll see what it ends up doing. I guess that's fine. We'll let it run. We'll see how it plays out. All right, we're gonna clear our context. And I'm gonna do my first commit here. So we're gonna create a new window. So there's my first commit. All right, let's get back to our other project. All right, now we're gonna start. All right, so we're gonna go ahead and implement phase 0 of our implementation here. There's two key things to this prompt. Test to make sure it works, because it won't test. It'll just assume it works if you don't ask it to test. And then if errors are found, make minimal changes to fix them. Minimal in caps. Make sure that it doesn't start hallucinating and adding all kinds of features and changing things as it's going through and changing to fix errors. And we'll do that a lot if you don't stress that you want minimal changes. It apparently changed from 0 to 1. Let me make sure that we're on the same page here. Boy, this design file has certainly gotten long. Step 0, step 0.3. Project setup and foundation. Phase 0, which I interpret as phase 1, foundation and safety. Let's make sure we're on the same page about what it's actually implementing here. Sometimes it'll get off the rails. There we go. All right, so we can go through here. Want me to create an app? Sure, let's create an app. Oh yeah, it's good. It's gonna go create a folder underneath. So yeah, we don't need that. Continue, we're good. So I know nothing about Next or Tailwind or anything like that. So it's made all those decisions for me. Oh, nice. It's going to set up Husky for me. Love that. React testing library. Nice. It knows all that. I don't have to do a lot of research here to figure out how to set up all the scaffolding. It's just going to do it all for me. All right, let's see how it's configuring my files over here. Looks like we have a joke stream. It's setting it up as its own little module here. I think I want all this stuff in my current folder. All right, it's gone a little bit off the rails. We made our project in the joke stream directory. All right. This is where we're gonna give it a little bit of context here. This server only supports all right, looks like we're up and running here. Let's see what we have. And come down here. All right. One test, two tests, one file. That's fun. Let's make sure to run in lint. Good to go. npm run build. Looks like we're up and running here. Even though it says it works, it's all smart to test. All right. Let's run our dev server and see where we're at. All right. We are going to flip over here and we're going to go to look at that, it's up and running. Coming soon, endless dad jokes for everyone. I love it. This is gonna be so much fun. All right, looks like we're good to go. Get out of there. We'll go back to our, well, let's stay here for a sec. Let's go look through and see what it actually did here. So created me a little git ignore. Yeah, looks good. ESLint. Okay. That's not what I expect from an ESLint, but I guess we can add more to it later. Just config, just setup. Next config, looks like we're good. Package JSON, added all these dependencies and dev dependencies. I think we're good. Oops, give me a sec here. CSS, whoops. We have a little README with instructions in it. These are all my tests. I don't think I need those anymore. I can delete those. TS config. All right, in our source, we have our apps, icon. Yeah, thanks. That was super brilliant. And globals. All right, we got all that scaffolding, components. Nothing in there yet. Config looks good. Lib utils. DW merge. Oh, Tailwind. Got it. Stores, types. Not really a fan of a types directory, but whatever. We have our public over here. Thanks, a whole bunch of icons. All right, I think we're ready to rock and roll. Let's go ahead and commit this. ESLint fix failed. We'll come back to this. Oops, something went wrong. All right, let's fix that. We're just gonna cut this in here. We'll come back up here. All right, oops. Let me escape out of that and get the error. When you do like fences around it, it helps the AI see where the differences are, which part's the actual error. All right, I think we're good to go here. Let's make sure that everything's working. Yeah, we're gonna ignore that warning. Hopefully that's right. Maybe we should just check just to make sure. Let's see what it actually says. Meh, doesn't seem like a big deal. We'll just move on with our lives. All right. Let's see where we're at. Seems like we're good. Let's come back here and let's implement phase 1. All right, looks like phase 2 is complete here. Let's see how we're doing. All right. All right, so we have our first version of of our web page up and running. Looks like we have our content filter strict. Let's make strict the default setting for our content filter. I don't know that we need a drop down. Maybe we'll just get rid of that in a second here. All right, so at this point, let's see where we're at. I think we're done with phase 2. Let's do some, take a little diversion here. All right, so we're gonna do a init, which is gonna create a Claude MD file. This will describe our project. So this is gonna analyze our code base, create a Claude file, and then we can add some instructions into it. All right, let's see what it did for our Claude file here. All right, so it includes development commands, includes an overview of our architecture, API integration strategy, testing strategy, key dependencies, implementation plan. Good stuff. All right. Looks like we're done with that. Oh, we're moving on to phase 2 here. Let's add a couple instructions to our Claude.md here. So first, let me go back and commit this. All right, now let's come back here. We're going to add something to our memory. Never write any files to jokes. I can choose which one we want to include this in. So local memory, project memory, user memory, which is stored for all my projects. We'll just put it here. And let's go back here and see what it actually changed. Cool. Never write any files to the joke stream directory. Got it. Let's see what else. All right. Anything else we want to add here? I think I had some few more things. I'll also add a test. Oh, after fixing a bug. All right, there we go. We added a few instructions into our Claude MD. Let's go back and we'll commit it now. All right, let's go back and implement phase 2. Okay, looks like we're done here. Let's see if it tests and passes and everything. All right, looks like we're done fixing all of our lint errors. That took forever, man. Let's see where we're at. Looks like our tests are running. Oh, we have one failed test. Let's see if our app still works here. Looks like we're good. Still on maximum safety. All right, ready to rock and roll. Let's commit. Move on to the next phase. Now, now implementing phase 3 is just as easy as changing a number. away we go. All right, let's see how we're doing here. Ooh, looks like we have a few things that don't have any test coverage. I don't know if that's a problem or not. Let's check in with Claude and see what it says. All right, let's see how we're doing here. All right, let's check our coverage now. Ooh, that looks better. Whoa. Now we have some lint errors. Let's go back and fix those. All right, let's see if we got there. All right, now the moment of truth. Is it gonna work? Is it gonna show anything? Nobody knows. Oh. Awesome. All right, so we have our infinite scrolling. Oh, cool. It has like little IDs in every one of them. I think I can favorite some of these. Not yet. Oh, there it goes. I don't know if that's yeah, it looks good. Oh, one issue. What do we got? I think that's because we're trying to do things that are part of a future implementation here. So we'll come back to that in just a sec. All right, cool. Looks like we have a working little bit of a demo. There's one thing here. When we click that, it's supposed to do this flip over thing to reveal the answer. Let's see if we can get it to do that. Maybe we're gonna stick with just the one part for now. We could implement it, but I think we'd have to test it out, make sure it works. So let's just get rid of the flip right now. Let's see where we're at. We should still have it running up here. Yeah, it's gone. All right, we have a infinite scroll. Oh, it does an infinite scroll. What happened? Are we supposed to have infinite scrolls implemented? All right, we still have some other bugs and things like that, but let's step back for a sec. It looks like we have a working implementation for the most part right now. Let's commit our code. Alrighty, and now let's go back and do a code review. So we're going to clear our context so we don't have any memory of everything that we just did. So this is basically like a new LLM that's not even going to know what's going on. Now we're going to ask it to do a code review to see what it thinks of its own code. All right, something interesting just happened here. We just hit our limit on Opus 4, which means that we've used 50% of our tokens for this 5-hour session. So that means that now we're running on Sonnet 4. I haven't really noticed any difference between the two. They seem to be pretty compatible and work equally well from my perspective. But now we're switched over, so we can show you the status in just one moment here. All right, let's see what's in our code review here. Well structured, separation of concerns, good testing, modern React. There are some areas regarding code duplication, as we'd expect from an LLM, maintainability, and potential bugs. High priority issues, direct store accesses and services. Creates tight coupling between the API. All right, I don't know that that's the end of the world. Inconsistent error handling. All right, well, that's something we can fix. Test setup duplication. Extensive duplication and test setup across multiple files. All right, so there's a little helper thing that we can implement. Magic numbers and configuration duplication. All right, we should solve that. Incomplete type safety. All right, well, that's not too bad. Animation performance, new animation variants. All right, so let's see what it does if we ask it to create a plan to solve these problems. We've got our implementation plan nailed down here, so let's go ahead and see what's in the implementation plan for fixing our code review here. That's our big implementation plan, code improvements plan. There we go. Refactor direct store access, update interface. So it's got a fairly detailed step-by-step plan here. Honestly, if people have feedback around how good or how bad the code looks, it'd be great to hear comments about like the code looks good, the code looks bad, here's things that we need to fix, would it pass our expectations for code review, things like that. So I think there's just one other thing that I want to show off real quick. So let me flip over to our shell. So there's a Claude best practices, and I'll get back to that in just a second. But one of the things in Claude best practices is integrating with the GitHub or GH command line tool. So you can type GH, and it'll allow you to do things like view issues, view pull requests, things like that. And so like Claude Code will actually iterate on issues and pull requests. It'll review them for you. It will look at issues and bugs that you have open in your repo, and actually you can just say work on this issue, and it'll go away and work on it and make changes. So you don't even have to have as much prompts as possible, and it'll update the issue and close issues and things like that. One of the things you didn't see in this demo is that Claude Code will actually commit and push code for you. So that's one thing to think about. For me, I have it turned off. I have a global level instruction not to commit or push code for me in my global Claude.md. So it will do a lot more automation for you. It's kind of nice too when you get into CI/CD types of tests to have it push and like debug what's breaking in CI/CD, especially if you can use the GitHub command line tool to see what's breaking in your GitHub workflows and GitHub actions. So that's one thing to think about. The other thing to think about is there's this thing called GitHub Worktrees, or I'm sorry, Git Worktrees. So Git Worktree basically creates a local branch of your code, a copy of the code with a branch. So I created a little tool called Worktree tool. Actually, before I do that, let me commit my code. Whoops. All right, so let me do Worktree init, so Worktree tool init. And so what this does is it creates this Worktree structure where now I can say like work tree tool, create feature one. And so now I'm in the feature one directory. You can see up here, like I'm in this work tree, and here's a complete clone of our repo that's independent from the main repository that's back here. So I'm now working on a Git branch that's now the feature one branch. And if I exit out of that, or if I just go back here, I can do work tree tool, create feature two. Now you can see I'm in a feature two. So feature one and feature two are two different things I can develop at the same time. As we're going through and doing all the demos, you could see that there were these 3-minute, 5-minute, 10-minute pauses where I was doing nothing. And it's like as boring as watching the Linux kernel compile. But if you start doing all these feature branches in parallel, you can actually do multiple development paths at the same time. So then you are just basically bouncing back and forth between Claude prompts in different windows and keeping them all going at the same time, trying to figure out where it's getting stuck, kind of keeping an eye on them to make sure they don't go off the rails, things like that. So you end up like almost being a farmer for like a whole bunch of different features at the same time. So the work trees are a really powerful tool for not just accelerating using AI tools, but going even faster. So that's one more thing to think about. All right, let's see where we ended up here. This demo's almost complete. I'm going to do one last little thing after I shut off the video, and that's like I'm going to have Claude create a GitHub workflow action. Actually, maybe I'll just do it right now. Oh yeah, so you can see my two new feature branches, feature one and feature two, if I want to work on those. All right, so clear and create a GitHub workflow that publishes my code. We'll see how that goes. All right, kind of silly that it runs lint after test. Let's fix that up. What else do we need here? I think that should probably do it. Set up pages, deploy to GitHub pages. All right, maybe this will work. We'll see. All right, I'm not going to delay this any further. Let me do one last thing. So we started this at 12:05, is currently just right around 5 o'clock. So it's been just shy of 5 hours. I had to step away in the middle there for like maybe 45 minutes or an hour. So it took about 4 hours to develop this entire demo. I haven't completed all the features that are in the implementation plan. I would guess, based on what's happened so far, it's probably about 4 hours worth of work to finish the entire implementation plan and all the other features that are in there. This has been one of the hairier projects that I've worked on in terms of like the infinite scrolling issues. Tripped us up for a little bit, got stuck on the Pokey API in the beginning. So I probably lost maybe, I don't know, 45 minutes or an hour of productivity in there somewhere. So probably about 3 hours on average, I would guess, for setting up a project like this. A little simple website, pulling data from an API, showing it on a page. Other things we could do in the future is showing like more UI refactoring and things like that. There's definitely more we could do, but definitely doesn't take a team of engineers to build like a scalable, maintainable, robust code set. I'd be very interested in hearing like the debate about like how good or how bad is the code, how good or how bad is the design. I did power through and do some really silly things. I probably should have read the design description a little bit more, implementation plan a little bit more. I got stuck on like the joke stream directory problem for a little bit, and I think that was probably in one of the implementation files that I could have caught. I could have put in the design like, hey, make it mobile friendly website, because I think that's what tripped us up on the infinite scroll, is it wasn't mobile friendly. So that seems like just a couple, like if I'd been taking a little bit more time and been a little bit more conscientious, I probably would have been able to save myself an hour or two in the middle of the project. But otherwise, I think it was pretty successful, and a little bit more work to do, but just a demo of how fast we can develop code with generative AI tooling. Feel free to hit me up with any questions, and I feel obligated to say like or subscribe. Thanks, y'all.